हेलो 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 नमस्कार दोस्तों, वेलकम बैक टू अनदर लाइव ऑफ आवर चैनल। और आज के इस लाइव में हम लोग पढ़ने वाले हैं बेलमैन फोर्ड एल्गोरिदम। हम लोग एज यूजुअल अब्दुलवारी सर का जो कोर्स है उसको हम लोग फॉलो करेंगे। एंड आई एम थिंकिंग अबाउट लाइक रिवीजन सेशन और लाइक काइंड ऑफ a stitch up session up until now on the like upcoming Saturday. So I'll let you know. I'll plan this session, and if possible I'll ask some of my friends who are currently working as software engineer in different companies to join me on that session. And if you guys are new here, then hit that subscribe button, and please let me know if you have any ideas. Actually, I do have a couple of friends who are working currently in this industry, software industry. So if you need something, some guidance or something like that, you can let me know. I will contact them, and I'll like they will be readily available for questioning your queries and all those things, because I am readily available for you guys. So without wasting any further time, let's jump right into it. तो हम लोगों ने कल हम लोग पढ़ रहे थे कल हम लोग पढ़ रहे थे मैट्रिक्स चेन मल्टीप्लिकेशन के प्रोग्राम के बारे में। तो ये हमारा कुछ प्रोग्राम था कि हमने पहले टोटल हमारी नंबर ऑफ जो क्या बोलते हैं डिस्टिंक्ट डायमेंशंस हैं वो ले लिया था n इक्वल टू 5। उसके बाद में एक एरे बनाया था इन्हीं डायमेंशंस का, डिस्टिंक्ट डायमेंशंस का। फिर उसके बाद में हमने एक रिजल्टेंट लाइक जो कॉस्ट जिसमें हम लिखेंगे वो वाली मैट्रिक्स बनाई थी, और जिसमें हम लोग बेसिकली लिखेंगे कि किसके बाद में हम लोगों को पैरेंथेसिस लगाना है, वो वाली एक मैट्रिक्स बनाई थी। उसके बाद में हमने जे यानी कि जो हम लोग लाइक रो और कॉलम में एडिट करेंगे ना, तो जो हम लोग कॉलम में एडिट करेंगे उसके लिए हम लोगों ने जे, मिन और क्यू को इनिशियलाइज कर दिया था। मिन बेसिकली मिनिमम कॉस्ट को स्टोर करने के लिए था, और क्यू जो था वो टेम्परेरी कॉस्ट को स्टोर करने के लिए था। उसमें हम लोग लाइक क्यू को कंपेयर करके मिनिमम के साथ में उसमें जो मिनिमम होगा उसको हम लोग मिनिमम में स्टोर कर रहे थे। फिर हमने, क्योंकि हम लोगों को डायगोनल पे चलना था, तो डायगोनल पे चलने के लिए हम लोगों ने देखा था कि इस वाले केस में, यानी कि जब हम लोग ये वाला डायगोनल देख रहे हैं, तो उस वाले केस में हम लोगों का जो डी है, यानी कि जो बेसिकली हमने डिफाइन किया था, क्या हम लोगों ने डी को डिफाइन किया था जे माइनस आई या फिर आई माइनस जे का मोड। तो वो हमारा कांस्टेंट है एक डायगोनल पे। अगर तुम देखोगे तो आई आई और जे का जो तुम्हारा क्या बोलते हैं डिफरेंस होगा वो कांस्टेंट रहेगा एक पार्टिकुलर डायमीटर के लिए, सॉरी एक पार्टिकुलर या डायगोनल के लिए, नॉट डायमीटर। एंड फिर उसके बाद में हम लोग क्या कर रहे थे, हम लोग हर एक डायगोनल के मतलब लाइक ये तो हम लोग का पहला जो लूप था वो डायगोनल को आइटरेट करने के लिए था। लाइक पहले ये वाला डायगोनल, फिर ये वाला, फिर ये वाला, फिर ये वाला। फिर हम लोग सेकंड लूप पे आए थे, ये डायगोनल के अंदर रोज को आइटरेट करने के लिए था, यानी पहला ये, दूसरा ये, तीसरा ये। फिर हम लोग जो इसके अंदर हम लोग ने ये के वाला बनाया था, ये बेसिकली हमारा था, हम लोगों का था कि हम लोग हाँ, ये हम लोगों का आइटरेट कर रहा था बेसिकली एक पार्टिकुलर बॉक्स और इन इन दिस, ठीक है, इन दिस मैट्रिक्स। एंड जो भी हम लोगों का मिनिमम कॉस्ट दे रहा था उसको हम लोग यहाँ पर लिख दे रहे थे, ठीक है। यहाँ पर देखो मिनिमम को स्टोर, जो मिनिमम कॉस्ट दे रहा था उस वाले इंडेक्स को स्टोर करा रहे थे, और मिनिमम कॉस्ट जो आ रही थी उसको भी हम लोग स्टोर करवा दे रहे थे, और फिर लास्ट में हम लोग आंसर कर दे रहे थे। तो इसका मैंने कोड भी लिखा था, तो वो अगर आपको चाहिए तो आप पुरानी वीडियो देख सकते हो, ये मैं कहीं आई बटन में डाल दूंगा ऊपर कहीं पर। तो स्टार्ट करते हैं आज की वीडियो।
Problem. In this video, I'll show how Bellman-Ford algorithm works and also the drawback of Bellman-Ford algorithm. The problem is, in a directed weighted graph, we have to select one of the vertices as source vertex and find out the shortest path to all other vertices. Let us say if I select vertex 1 as 1 as starting vertex, then I have to find out the shortest path to all of them. Now for doing this, already we have Dijkstra algorithm that will solve the shortest path problem. But Dijkstra algorithm will not work if there are negative edges. It will not work properly. It may give correct result, it may not give correct result. So we cannot use Dijkstra algorithm here and confirm that it's giving correct answer. So we want an algorithm which confirms that the answers are correct, so that algorithm is Bellman-Ford, and it follows dynamic programming strategy. So dynamic programming strategy says that you try out all possible solutions and pick up the best solution. So here we want to try out all possible solutions and pick up the best solution.
लाइक आप मुझको यस, सो मैं लाइक कीबोर्ड को भी इसमें पेयर करवाने की कोशिश कर रहा हूँ। अगर कीबोर्ड पेयर हो पाएगा तो बढ़िया रहेगा। आई गेस हो जाना चाहिए। हाइड्रा के अभी नहीं पेयर हुआ है। यस, पेयर हो जाओ, पेयर हो जाओ। पेयर हो गया। कांट कनेक्ट क्यों बोल रहा है भाई? यप, पेयर हो गया। तो हम लोगों को इसमें डालते हैं 4। हो रहा है अभी, तो हम लोग देखते हैं बाद में।
How we will try all of them.
बेसिकली
So
अभी
this
हम
algorithm
लोग
says
ऐसे
that you
देंगे।
go on relaxing all edges. How many times? All edges you repeatedly relax them for n minus 1 time. What is n here? N is the number of vertices. Number of vertices are 7. So I should relax them for 7 minus 1. What is the idea here? If from the source vertex, if the longest distance may be of all edges, then total how many edges may be there? So from 1 to 7, there can be maximum 6 edges. So if you are going on relaxing the edges, we may get a longest path also that is of 6 edges. Right? So it will cover all possible paths if you relax all of them for.
फिर से देखते हैं क्योंकि मैं मेरा ध्यान
Before
रखना
doing this, the topic is single source shortest path problem. In this video, I'll show how Bellman-Ford algorithm works and also the drawback of Bellman-Ford algorithm. The problem is, in a directed weighted graph, we have to select one of the vertices as source vertex and find out the shortest path to all other vertices. Let us say if I select vertex 1 as 1, starting vertex, then I have to find out the shortest path to all of them. Now for doing this, already we have the Dijkstra algorithm that will solve the shortest path problem. But Dijkstra algorithm will not work if there are negative edges. It will not work properly. It may give correct result, it may not give correct result. So we cannot use Dijkstra algorithm here and confirm that it's giving correct answer. So we want an algorithm which confirms that the answers are correct, so that algorithm is Bellman-Ford, and it follows dynamic programming strategy. So dynamic programming strategy says that you try out all possible solutions and pick up the best solution. So here we want to try out all possible solutions and pick up the best solution. How we will try all of them? So this algorithm says that you go on relaxing all edges. How many times? All edges you repeatedly relax them for n minus 1 time. What is n here? N is the number of vertices. Number of vertices are 7. So I should relax them for 7 minus 1. What is the idea here? If from the source vertex, if the longest distance may be of all edges, then total how many edges may be there? So from 1 to 7, there can be maximum 6 edges. So if you are going on relaxing the edges, we may get a longest path also that is of 6 edges. Right? So it will cover all possible paths if you relax all of them for 6 times. So what's relaxation? If I take any two vertices, let us say 2 and 5, and I know some distance of this vertex, the path to this vertex and the path to this vertex also, then I should see that if the path of this one plus this is less than this one. If so, I will change this one. So I will call them as u and v, and I will write down what does relaxation mean. So then once I start using it, I can explain you how it works. So relaxation means what? Between a pair of vertices u comma v, if there is an edge, then check if the distance of u plus cost of an edge u comma v is less than distance of v. If so, then change the distance of vertex v to distance of u plus cost of an edge u comma v. What is that? I will explain you while solving this. Now let us follow the algorithm. What the algorithm says, you prepare the list of all edges. Prepare a list. So which edge I should select first? You select any edge. First you select this one, then this one, or this one, or this one. You select anything, but make sure that all edges are selected. So I'll select them vertex by vertex. So I'll write down the list of edges here. There are total 10 edges. I have taken all 10 edges here, list of edges. Now I have to relax all these edges for 6 times. Now let us start the procedure. For that, initially I have to mark the distances of all these vertices. So this vertex, let it be 0, and for all other vertices, mark the distance as infinity. Mark it as infinity. All are infinity. Now start relaxing the edges. Now I will show you how that relaxation procedure works. First edge, 1, 2, 1 to 2. What is the distance of this one? 0. What is the distance of this? Infinity. 0 plus 6 is less than infinity. 0 plus 6 is less than infinity. So change this infinity to 0 plus 6. So make it as 6. The next 1, 3, 0, and this is infinity. So 0 plus 5 is less than infinity. So change this to 5. 0 plus 5 less than infinity. So change it to 5. So first 3 edges completed. Now 2, 5. 2, 5. This is 6 minus 1. This is infinity. So this is 5. 6 minus 1 is 5. This is already changed. You see. 3, 2. So 3 to 2. So this is 5 minus 2 is a 3. So change it to 3. Then 3 to 5. So this is 5 plus 1 is a 6. And it is 5. So that is smaller. Don't modify that one. 4, 3. 5 minus 2 is a 3. So this becomes 3. Then 4, 6. 5 minus 1. This is 4. This is infinity. So change it to 4. Then 5, 7. So 5 plus 3 is 8. This is infinity. So change it to 8. 6, 7. 4 plus 3 is 7. This is less. So change. So most of the changes we have seen first time only. Let us continue. Second time. 1, 2. So 0 plus 6. 6 and 3. So this is greater than that one. So don't change that one. 1, 3. 0 plus 5. 5. That is 3. Don't change that one. 1, 4. 0 plus 5. This is 5 only. No change. Then 2 to 5. 2 to 5. So 3 minus 1. 2. This is 2. That is changing again. So 3 to 2. So 3 is how much? 3. 3 minus 2 is 1. So this will change. 1. Then 4, 3. 4, 3. 5 minus 2. This is 3. This is perfect. 4, 6. 5 minus 1 is 4. Perfect. 5, 7. 5 is how much? 2. And 2 plus 3 is 5. This is 7. So change it to 5. Then 6, 7. 4 plus 3 is 7. And it is 5. No change. Let it be as it is. I have completed 2 times. 4 more times I have to do. 1, 2, this will not change. 1, 3, this will not change. 1, 4 also will not change. Then 2, 5. 1 minus 1. This becomes 0. This becomes 0. Right? Then 3, 2. So 3 is how much? 3. 3 minus 2. 3 minus 2 is 1, already 1. Now no more changes. Then 3 to 5. So this is 3 plus 1, 4. Already it is 0. That is better. 4 to 3. 4 to 3 is how much? 5 minus 2. That's 3. No change. 4 to 6. 4. No change. 5 to 7. 5 is how much? 0. 0 plus 3. 3. This becomes 3. Then 6 to 7. 4 plus 3. 7. That 3 is better. Right? So I'm updating there only. So 3 times I have completed. 3 more times I have to do. 1 to 2 will not change. 1 to 3 will not change. 1 to 4 will not change. 2 to 5. 2 is how much? 1. 1 minus 1, 0. That is not changing. Then 3 to 2. So 3 to 2, 3 is how much? 3 minus 2, 1. 1 is already 1. Then 3 to 5. So this 3 plus 1, 4. That is better. 0. 4 to 3 will not change. 4 to 6 will not change. Then 5 to 7. 0 plus 3, 3 only. 6 to 7, no change. Now this has stopped changing. So what are the results I got? What x1 is 0, what x2 is 1, what x3 is 3, what x4 distance is 5, what x5 distance is 0, what x6 distance is 4, what x7 distance is 3. These are the distances I got. If I continue for 2 more times also, I'll get the same result. So finally, these are the shortest paths. You can observe that. So as I'm doing it manually, I have stopped. But when you write in any algorithm for doing the same thing, it will continue for n minus 1 time. And some graphs may get the shortest path in just one time relaxation only, and some graph may relax completely, get the shortest path in the last relaxation. So in this graph, we find that after the third one onwards, there are no more changes. I have become the shortest paths. So this is how Bellman-Ford algorithm works. Let's get the time complexity of Bellman-Ford. What it is doing, relaxing all edges. How many edges are there? E edges are there. How many times it is relaxing? V minus 1 time. So this is order of V into E. So if we say V and E are n, so this will be n square n. So it depends on the number of edges. If this is a complete graph, then how many edges will be there in a complete graph? A complete graph means there's an edge between every pair of vertex. So total how many edges will be there? N into n minus 1 by 2 edges will be there. So if these many edges are there, then the time will be n into n minus 1 by 2 into number of vertices minus 1, n minus 1. So if you simplify this one, this will be order of n cube. So in case of complete graph, Bellman-Ford algorithm may take even n cube time. Right? Otherwise, minimum time we say it takes n square, and at most it may take n cube time. That is if the graph is complete graph. Now we'll take a small example and solve it, and also I will show you drawback of Bellman-Ford. A small example, I will take the list of edges. First of all, I will take the edges starting from here. First I will take 3, 2, then I'll take 4, 3, then 1 to 4, then 1 to 2. See, just to make you feel how the relaxation are done, I have taken the vertices in reverse. I should have started from vertex 1. Now let's solve this. My source vertex is 0, and mark all of them as infinity. Mark all of them as infinity. How many times I should relax? There are 4 vertices, so I should relax that for 4 minus 1, that is 3 times. So let's relax all the edges one by one. First 3, 2. Infinity minus 10 is infinity only, so that is no change, it is already infinity. 4, 3, infinity plus 3 is infinity only, and is already infinity. Then 1, 4, 0 plus 5, 5 is less than infinity, so change it to 5. Then 1, 2, 0 plus 4, 4 is less than infinity, change it to 4. One time I already have relaxed. Second time, 3, 2, infinity minus 10 is 4, that is better. 4, 3, 5 plus 3 is 8, this is better than infinity, so make it infinity. 1 to 4, 0 plus 5, 5 only. 1 to 2, 0 plus 4, 4 only. 2 times I have completed, 1 more time I have to complete. Let us check. 3 to 2, 8 minus 10 is minus 2. Minus 2 is smaller than 4. Now you can see that I got the correct answer for vertex 2 now. Then 4 to 3, 5 plus 3, 8 only. 1 to 4, 0 plus 5, 5 only. 1 to 2, 0 plus 4. And that is not greater, not less than minus 2. So minus 2 is better. Let it be as it is. So I have relaxed them for 3 times and I got the shortest paths. So what are the shortest paths? Vertex 1 is 0, vertex 2 is minus 2, and vertex 3 is 8, vertex 4 is 5. These are the shortest paths from starting vertex as 2. So Bellman-Ford has got the answer even when there are negative edges. So this is the answer. If I relax this for one more time and see let us what happens, 3, 2, 8 minus 2 minus 2 only, 4, 3, 5 plus 3, 8 only, 1 to 4 and 1 to 2, all are same. So if I relax one more time extra also, there is no change, that means the answers are perfect. Now let us see the drawback of Bellman-Ford. I will take the same graph only, but a small change. The same graph, I will add one more edge, that is 2 to 4, and I'll make it as 5. So this is 2 to 4. Now let us relax them. I have to relax them for 3 times. So quickly I will do it because already till here I was doing it. Let us do. So 0, infinity, infinity, and infinity. 3 to 2, infinity only. 4 to 3, infinity only. 1 to 4, 0 plus 5, this is 5. 1 to 2 is 0 plus 4, this is 4. Now 2 to 4, 4 plus 5, 9, this 5 is better. No need of changing. One time over. Now 3 to 2, infinity minus 10, that is infinity. So 4 is better. 4, 3, 5 plus 3, this is 8. Then 1 to 4 is same thing only. 1 to 2 is same thing only. Then 2 to 4, 4 plus 5 is 9, and this is 5, that is better. 2 times completed. The third time. 3 to 2, 8 minus 10, minus 2. Then 4 to 3, 5 plus 3 is 8, 8 is there. 1 to 4 is 5 only. 1 to 2, 0 plus 4, so minus 2 is better. Then 2 to 4, minus 2 and 5 is 3. This 4 is changing. Right? So this was the third time I have done and I got this answer. Let me try for one more time. Already n minus 1 time I have done. But let me try one more time and check. 3, 2, 8 minus 10 is minus 2 only. Yes. 4, 3, 3 plus 3, 6. Oh, this is changing. 1 to 4 will remain same. 1 to 2 also remain minus 2 only. And 2 to 4, minus 2 to 5 is 3 only. Minus 2 plus 5 is 3 only. So one more vertex has just now relaxed. That should not happen. After completing for n minus 1 time I should get the answer. If I repeat it for one more time, if I relax all the edges, there should not be any change at all. If I do one more time, again something will change. See, 3, 2, 6 minus 10, minus 4. So that's what, there's a problem. So why we got this problem? Bellman-Ford is unable to solve this one. After performing for n minus 1 time also, I'm not getting the correct answer. Still they are getting relaxed. So even if I do it without Bellman-Ford directly, if I try to do, I cannot solve it. Reason is, there is a cycle of edges, that is 2 and 4 and 3. So this is forming a cycle. This is minus 10 and 3 and 5. So if I add this, 5 plus 3, 8, minus 10 is minus 2. The total weight of a cycle is negative. So in this way, I'll be going on getting the path reduced every time. So there is no end of this one. So I cannot decide or freeze the answer. So if there is a negative weight cycle, then graph cannot be solved. Right? So Bellman-Ford fails to solve the graph if there is a negative weight cycle. Total weight of a cycle is negative. If it is positive, it will work. So if the weight is negative, it will not work. That's all. then.
Weight cycle.
But the Bellman-Ford algorithm can detect if there is a negative weight cycle or not, because after performing for n minus 1 time, so we can relax one more time and check if the vertices are getting relaxed. If any of the vertex is getting changed, then it means there is a negative weight cycle. So that's all about dynamic programming, Bellman-Ford algorithm.
Also. हाँ भाई, डायनेमिक प्रोग्रामिंग इतना ज़्यादा सुन लिया, इतना ज़्यादा पढ़ लिया उतने दिनों में, लेकिन दिमाग जो है वो अभी भी लाइक उस लेवल पे नहीं है। मुझे लग रहा है मुझे प्रॉपर बैठ के प्रॉब्लम सॉल्विंग भी करनी पड़ेगी, उसके बाद में थोड़ा सा कॉन्फिडेंस आएगा। और एक एल्गोरिदम के अराउंड मुझे 3 से 4-5 सवाल करने होंगे। उससे पहले मुझे एल्गोरिदम का क्विज टाइप में लेना होगा, ताकि मुझे एल्गोरिदम की सारी चीज़ें पता चलें कि लाइक उसकी टाइम कॉम्प्लेक्सिटी से लेके सब कुछ दुनिया भर का जो भी होता है वो क्या होता है, कैसे होता है, ठीक है, और एल्गोरिदम एक्चुअली में क्या होती है। तो नाउअडेज आई वाज लर्निंग दिस लाइब्रेरी कॉल्ड मैनेम इज बेसिकली मैथमेटिक्स एनिमेशन लाइब्रेरी। आई वाज यूजिंग पाइथन, मैनेम मैनेम पाइथन module of it, and I found that 3 blue 1 brown also use this particular library to make their videos. I also tried to make a couple of videos, if I'll show that to you. So let me show that to you. I tried making a couple of videos. Media Manning course 120p. Yep, so I tried making a couple of videos. Here you can see this binary search video. I created it using Manim library. This is somewhat similar to what we see in 3 blue 1 brown video. So I have used that particular library itself, but this library is very extensive, so there are a lot of things that I do not know currently. So I was using this for plotting a graph, simple like a parabola, and using those rectangular areas up under the chart. And here I was moving the rectangle along with this arrow and making the circle smaller. So just practicing some basic animations. And this was for testing text and shapes, and after moving also animating those text and shapes. So I was learning this also. तो अभी चलो नैपसैक पढ़ लेते हैं आज की इस वीडियो में, क्योंकि मुझे लगता है कि अगर हम लोग नैपसैक पढ़ लेंगे तो लाइक डायनेमिक प्रोग्रामिंग का एक ठीक ठाक आइडिया हमको हो जाएगा। क्योंकि नैपसैक is, I guess, because like I did a course in my first year where they like introduced us to dynamic programming, giving the example of this particular problem. And I think Abdulwari sir also like already talked about this problem, but at that time I don't think we had the like we was able to divide these unit values. So kind of whole values we could take, whole amount of those particular values we could take, and we could not divide. I think at that particular time we could not divide, but I think in this problem these weights would be divisible, I guess. So let's watch this video also. So in today's video we will be like doing we will be getting done with 2 of the videos of Abdulwari sir. Number first was Bellman-Ford algorithm, which is for single source sorted path, and number second would be this knapsack problem one. So let me create a page called knapsack problem. And this would be 4.50 out of 1. I don't know why this particular nomenclature is being followed.
The problem is zero knapsack problem. In this video, I will explain what is zero knapsack problem and how it can be solved using dynamic programming.
Oh, 0-1 no.
Next, I will show you a tabular method for solving this one. Then also I will show you a sets method for solving this one.
So इसमें वही है कि ये divisible नहीं होगा, जो तुम्हारा weights या जो भी तुम्हारे amounts है वो divisible नहीं है इसमें।
For each object there is some profit and there is some weight, and there is a bag of capacity m, that is 8 is given. The objective is to fill this bag with these objects. So can I put them all? See, the capacity is 8, but the total weights of all these objects is 14. So all objects cannot be filled in the bag. So I have to carry some of those objects, there is a subset of those objects, and I have to carry them and sell them at other place. So once I sell, I get this profit. So I have to fill the object such that the total profit is maximized. And I have to give the solution in the form of a set for each object. Like, for example, this is included and this is not included, or not included. Like this, I have to write down which one is included and not included. So it means I can write down each xi either 0 or 1. Means the values can be 0 or 1, but not fraction. So it means that the object that I am going to carry are not divisible, breakable. So I cannot take the fraction of that object. So this means these are some solid objects. Maybe a mixer or microwave oven or a router. It can be something like this. So which I cannot take a half of a mixer in the bag. So these are indivisible objects. So either I should carry the whole object or don't carry it at all. So I have to carry the object such that the sum of their profits should be maximized and some of their weights should be less than or equal to the capacity of the bag.
Yeah.
Now let's know the approach of dynamic programming for solving this one. Now, few important things about dynamic programming. Dynamic programming is useful for solving optimization problem. Yes, this demands maximum results, so it's optimization problem. Second thing, dynamic programming says that a problem should be solved in sequence of decisions. So yes, we can take the sequence of decisions for every object. We can take, shall I include or not, include or not, include or not. So I can take decisions. I can even start taking the decision of the last object also, include or not, include or not. So usually in this one, we take the decision from last object towards first object. So we can take sequence of decision. Next thing, one more point that dynamic programming says that you should try all possible solutions and pick up the best one. Now, how many possible solutions are there? See, when I'm writing the solution in the form of zeros and ones, then it can be 0, 0, 0 means no object is included, or 1, 1, 1, 1 means all objects are included, or 0, 0, 0, 1 means only fourth object is included, or first object is included, or first two objects are included. Like this, there are many possible solutions, and some of them may be feasible, some may not be feasible. Like all objects I cannot include. So anyway, I should try all of them and pick up the best one. So total how many solutions will be there? So like 4 zeros and ones form if I continue, so I'll be getting 2 power 4 solutions. So I should try 2 power 4 solution. For n objects, it will be 2 power n solutions. So if I try out all, then the time complexity will be 2 power n. This is too much time consuming. So dynamic programming shows an easy method for doing the same thing. We will be indirectly trying all 2 power n, right? But not directly. So we will not spend that much time. Let us solve this problem using tabulation method. Tabulation method, let us see how to fill these values and how to get the solution for this problem. So for solving, as the capacity of the bag is 8, so I have taken the columns starting from 0 to 8. So this means that though the capacity is 8, but we'll not consider that 8 at once. So we'll add weight one by one. So starting from 0, then let us assume weight is 1, weight is 2, and so on. Then rows. 4 objects, so I have taken 5, 0, 1, 2, 3, 4. So starting from 0. So it means one by one we will consider the object. So initially we will not consider any object, means we will not include any object in the bag. So for filling this, we have a formula. So I'll show you formula after some time, after filling some values. So let us see. First row, as a 0 object, no object is included, then what will be the profit? So in these boxes, I'll be writing the profit. So there's no profit gained when no object is included. And even when the capacity of the bag is 0, this is the capacity, these are the weights, right? And these are weights and the profits of the objects. So these are the weights, and there is then 0 weight is there, then all these are 0, 0, 0. Next. Now we'll start filling. So for that, I'll consider first object. When I consider first object, I'll take this row, and I will ignore all other objects. And similarly, when I go to second row, I'll ignore the remaining and I will take the second object as well as the first object. I'll consider the first object also. So it means whenever I am in ith row, I will consider all the objects in the previous rows also. So for the first row, directly I can fill it. Let us see. First row, what is the weight of the first object? 2. So it can be filled only when the bag capacity is a 2. So here, so what will be the profit? 1. So fill 1 here. Then this means this is same value, previous value. Usually we write previous value only if required. Then rest of the cells, the capacity of the bag is increasing, but how many objects I am considering? Only 1. So I don't have anything more to fill in the bag. So only that object I can fill and I will be getting profit as 1, 1, 1 only. I'll fill the second row also, right? Third row also in the same way. Then I will write down the formula. Let us go to second row. I'm going to consider second object. So as I said, when I consider second object, I should also include the first object. So first let us look at the second object. See, the weight of the second object is 3. It can be filled in the bag only if the capacity is a 3. So in this cell only it can be filled. So what is the profit that I'll get? 2. So put 2 here. What about this side? It will be same value as the previous row. Then beyond this, what should come here? So as I said that when you are taking second object, you should also consider first object. So if I fill the second object also in the bag, total weight required is how much? 5. So this is 5. And total profit will be 3. So both the objects can be filled when the capacity is 5. And the total profit will be 3. So here both of them can be filled. Right? Both of them. I'm considering both of them. So now I have only 2 objects and this is giving for both objects are filled. So rest of the values will be 3, 3, 3. Then what will be the value here? So as this is 2, so this will also be 2. So I can take the previous value or this value, whichever is maximum, I can take the same thing. Now I will fill the third object also. Then for the fourth object, I will show you the formula. Third object. When I consider third object, if you look at these, the maximum weight is this one, and as they are arranged in the increasing order of the weight, so this is weight is 4. So this object can be filled in the bag only if the capacity of the bag is 4. So this will be included in the bag when the capacity is 4. So the total profit that will be getting is 5. So this is 5. Then before that, whatever the previous row values are. So 2, 1, and 0. Now beyond this, let us see. See, when I am on the third object, I should also consider first and the second object also. So if I just check them, this is 4. And if I take these 2 objects, it will be total 6 weight. Weight is 6. So these 2 objects I can fill if the weight is 6. Right? So if I want to fill these 2, then these 2 I can fill if the weight is 7. This 2 I can fill if the weight is 5. And what will the profit? 3. This object itself is 5. Right? Now, I will consider these 2, 6. And the total weight will be 6. So at 6, it will be 6 only. Right? And when I consider these 2, so total is 7. 7. Okay. And the profit is also 7. So at 7, the profit is 7. Can I include all 3? It will be 10. But the capacity of the bag is only 8. So I cannot include all 3. Then beyond this, the value will be 7 only. And before this one, the value will be same as this 5. Right? Alright? Now,
थोड़ा पल्ले पड़ रहा है.
That formula. The formula is like this. If I call this table as V, then V of I, W, I is the row number, W is the column number, is maximum of V of I minus 1, that is from the previous row, I should take, same value, means previous row value I should take, this is the meaning, or maximum of this one, or what, V of I minus 1, weight minus weight of an object, Wi, plus profit of an object, that you are considering. Now let us follow the formula and fill all these. First one, 4 comma 1. I will fill 4 comma 1. So v of 4 comma 1 is maximum of v of 3 comma 1. Like this is 4, so this will be 3, comma v of 3 comma, weight is how much? 1, minus weight of an object. Weight of an object is 5. 1 minus 5 plus profit of that object is 6. Now this becomes 3 comma minus 4. There is no such location, so that value becomes undefined. So only this value will be defined. V of 3 comma 1 will be defined. So v of 3 comma 1 is what? 0. So I should take 0 only. There will not be any such index v of 3 comma minus 4. Yes, for that I have to take 0 only. So it means up to what I will be getting negative numbers? Up to fifth weight. So till here I should fill these values as it is only. So that's what I was saying, that this can be considered, or this can be considered in fourth. So write down its value and all previous values as it is. So the same thing here, because they will be getting negative. So till fifth weight, before that I have filled as it is. Now this fifth weight, how to fill, I will show you. For this value, 4 comma 5, v of 4 comma 5 is maximum of v of 3 comma 5, comma v of 3 comma, weight is how much? 5, minus weight of this object is how much? 5, plus profit of this object is how much? 6. Let us see. V of 3 comma 5. 3 comma 5 is how much? 5. Comma. V of 3 comma 5 minus 1. 5 minus 5, 0. V of 3 comma 0. 3 comma 0 is 0. Plus 6. So which is greater? 6 is greater. So fill this value with 6. So that means this object is included here. Now 4 comma 6 I will find out. V of 4 comma 6 is maximum of V of 3 comma 6, comma V of 3 comma, weight is 6, right? And the weight of the object is 5 plus profit of the object is 6. So how much this is? V of 3 comma 6 is how much? 3 comma 6 is 6. 6 comma V of 3 comma 6 minus 1. 6 minus 5 is
समझ में नहीं आ रहा है,
3
बहुत
comma 1 is how much? 0.
कॉम्प्लेक्स मामला लग रहा है.
So take 6.3. Next one, 4 comma 7. V of 4 comma 7, maximum of V of 3 comma 7, comma V of 3 comma, weight is how much? 7. So weight of the object is 5. 7 minus 5 plus profit is 6. So this is 3 comma 7 is how much? 7, comma. This is V of 3 comma 7 minus 5 is 2. 3 comma 2. So 3 comma 2 is how much? 1 plus 6. So this is 1 plus 6. So this is 7 only. Both time I'm getting 7 on 7. So they are same only. Take 7. V of 4 comma 8. 4 comma 8 is maximum of V of 3 comma 8, comma V of 3 comma, weight is 8 minus the weight of an object is 5 plus profit is 6. 3 comma 8 how much? 3 comma 8 is 7, comma V of 3 comma 8 minus 5 is 3. 3 comma 3 how much? 2. So this is 2 plus 6. So how much this is? This is 7 and this is 8. So answer is 8. So this is how the table is filled. So I have used the formula for few cells in the last row, and this can also be filled directly also without the formula. Let me show you how to fill this last row directly. I'm considering
Hi, so we have concurrently 2 viewers right now.
Just write 6, it's profit.
Hi guys,
And what to write
if
on
you
the
are new
cell
here,
before that, same value.
so let me tell you, we are doing this algorithm confidence quest. This is a series in which I'm trying to learn or sharpen my algorithmic ability. So currently we are at the, I think, currently we are at the video number 54th of this particular playlist. I do have a couple of previous lives in which I try to learn these algorithms live, and I made this particular series only because of me not being consistent enough with all those things, with all these learning things. That's why I tried to give myself a social platform where I am expected to put my face out there, and I am expected to be live on a particular time so that I could learn these things. This is kind of a social pressure induced self-motivation kind of thing. That's why I started this live thing. So if you are new here, you can connect with me on Instagram, and there are links in the description itself. There are links to my Instagram, and in the channel description you can find my Instagram and LinkedIn also. I do have a same username on X, which was known as Twitter also. So I do keep posting the stuff related to all these programming things there also, so you can follow me, you can check me out there also. And currently I was thinking of making currently I'm thinking of making a 5 or 6 hour long video, not video per se, a live kind of thing, where I'm thinking of doing lead code from scratch and ground zero. I will be making a new account and I will be grinding lead code for 6 hours straight. I'll be eating food live on the camera. I'll be cooking if I need to. So I I'm thinking of doing it on upcoming Saturday, so I'll let you know. I'll let you guys know, and I'll post it in the community section of my YouTube channel. Also, I'll try to be as open as available on these social platforms as I could. So let's start this thing. So currently no viewers are there. Let's start this video.
The previous row. This is what you do first. Done. Beyond this, now the weight is 5. Beyond this, the capacity of the bag is increasing, so I can include other objects also. So let us check other objects what I can include. In the sixth column, this object is definitely because its profit is maximum, right? 5 plus 2, 7. At 6, nothing will happen. So take 6 only. At 7, I can consider these two. So this is 6 plus 1, 7. Then at 8, when the bag capacity 8, which of the objects I can consider? 5 plus 3,
5
8.
plus
So 6,
3
7,
and
2,
5 plus
8.
2.
So this is 8. So whichever objects that you can consider, you just add them, and in that capacity if they are fitting in, you write down the max total profit. So this is a simple method for filling the cells. Instead of following this complex formula, you can follow that method. So I have shown you both solution. I have to write down x1, x2, x3, x4 values. Now for finding these answers, actually I'll be taking sequence of decision now. See, the decisions can be taken only if you have the data. Yes, we have kept the data ready. The formula was used for filling this data. Now I have to take the sequence of decision. So how to solve? So actually I have to know which object should be included and which should not be included in the bag. So let us come with the maximum profit, that is 8, the last cell. This 8 is generated only in 4th row, and in that previous row you don't find 8 anywhere. So it means we got this 8 because of including 4th object only.
Yep.
So include the 4th object. Right? Profit is 8. 4th object is included because 8 is not in previous row. Now what is the profit of the 4th object? 8 minus profit is 6.
6.
So this is 2. Now
Which
remaining
means
profit is 2.
remaining
Now check.
profit
Whether 2
is
is there in the
2.
third row. Now I have to check for the third object. 4th, then 3rd, then 2nd, and then 1. So third object 2 is there? Yes. The same
Yes.
value 2 is there in the previous row also? Yes, it is there. So it means it is not because of third object. So don't include third object.
Yeah. So
Now
it
let's
is
consider second
because
object.
of
Is 2 there here in
second
row? Yes, 2 is
object.
there here. Is it there in the first row also? No. So
No.
it means this we got because of inclusion of the second object.
Second
so take this
object.
as 1. So now remaining is 2 minus 2. So 0.
0. So we do
0
not
was
have
there in
any
the first
profit
object? No, consider
left.
the first object. Yes, 0 was there in the first object row. Was it there in the
So
0 also? Yes, it was there in the 0th also. This row also. So it
we
means don't include
will-
the object. So this
we
is the
will
solution.
not
So it
include
means which objects are included in the
the
bag?
first
X2
object.
and X4. 2 objects are included in the bag. So that is X2 is this one, X4 is this one. So total profit will be 8. So this is the maximum profit of 0 knapsack problem. Next I will solve it using sets method. Same problem I will solve it using set method. Now let us solve it using
Set
set method.
method.
Set method will try to find all possibilities and pick up the best solution. So let us see how
Okay.
sets are generated. We will prepare a set of order pair that is profit and weight. So we'll start with the set 0. Set 0. In this we say no profit, no weight.
No
Means nothing is
profit,
included in
no
the
weight.
bag. Then we will consider the first object, that is 1, 2, whose profit is 1 and the weight is 2. So
Weight
consider the
is
first
2.
object, so prepare S0
So
of 1.
S0 of 1
Include
would
this first
be
object in the bag, so it will be 1,
1, 2.
So actually add 1, to this order pair, so we get this one. Now prepare set 1. Then merge these two order pairs and prepare this one. So this means that we have considered first object. So two order pairs are showing that first object is not included, first object is included.
First object is
let's
included.
prepare
Okay.
next set by considering second object. So that is 2 plus 3. So prepare next set, that is S11. So add 2, 3 to these order pairs. 2 plus 3. So this is 2, 3. Then 2 plus 3 is added. So this will become 3 plus
3 plus
5.
3, 5. Yep.
This is second set for the second object. So when you consider second object, total 4 order pairs. All these are merged. So this is 1, 2 and 2, 3 and this is a 3, 5. This means that no object is included. First object is included. Second object is included. Both objects are included. 4 possibilities are there. So all the order pairs we got. Then prepare S2 of 1 by considering third object 5, 4. Add 5, 4 to all. So this 5 plus 4. So this is 5 plus 4 is 5, 4 only. So 5 plus 4, so this will become 6 and 6. So this is 6, 6. 5 plus 4, so this is 7, 7. So 5 is added to this and 4 is added to this. So this becomes 8, 9. 8, 9. Now merge all these and take order pair. So set 3 we get as 0, 0, 1, 2, then 2, 3, then 3, 5, then 5, 4, then 6, 6, 7, 7. Now here 8, 9, profit is 8 and the weight is 9.
Weight
so
is
that is
9.
exceeding the capacity of the bag.
So which is
Don't include that.
exceeding, so we will
So
not
we have discarded that, right?
include it.
Now this is set 3. In this one if you observe, this is profit, this is weight. Profit increase, weight increase. Then from this profit increase, weight also increase. Profit increased and the weight also
Weight
increased. But
is
here
also-
profit increased, weight is decreased. from
Weight
5.
is decreasing.
This is not possible. Profit is increasing, so the weight is also increasing. But weight is decreased. How it is possible? So that's why this order pair are wrong. So we have to discard anyone. So we will discard the one with the lesser profit.
Lesser profit.
So 1, 2, 3, 4, 5, 6. Now we have only 6 order pairs because 2 were invalid. One was this was giving wrong values and this was exceeding the capacity of the bag. So cutting off this one we call it as the dominance rule. So with the dominance rule the values order pair is discarded. Now I will consider fourth object 6, 5. I will include. So I will prepare set 3
Dominance
by considering
rule.
fourth object 6, 5. So first order pair is 6, 5. Next order pair is 6 and 5 are added. So this is 7, 7. And then 6 and 5 are added. So this is 8, 8. And then 6 and 5 when they are added it will become 11, 9. 6 and 5 added, so this becomes 12, 11. And 6, 5 when added to 7 and 7, so this becomes 13, 12. Now I have to prepare set 4. This is the final set. Merge these order pairs. So 0, 0 is taken from here, 1, 2 and 2, 3 and 5, 4, 6, 6 and 7, 7. They are coming as it is. Now in this one, 6, 5 is there. So 6, 5 should come before 7, 7. So 6, 5. Now here again you see the profit is remaining same, but the weight is reducing. So this should be removed. Then 7, 7 is there. Then 8, 8 is there. Then remaining 11, 9 exceeding the capacity of the bag, 9, 11 and 12. So all 3 order pairs are gone. So these are the ordered pairs I have. So if you observe, the method is generating all possibilities. So this is one easy method of finding all possibilities. So the time taken by this one is almost 2 power n. Now what is the solution? So we have all these sets. Now we take the sequence of
What
decisions
is
to solve
the
this one. Now it's the maximum order
solution?
pair, 8, 8.
Is the
So 8, 8. Now using that, I will solve this one. So the approach is similar like what we saw in the tabular method. 8, 8 belongs to set 4. But 8, 8, check whether it belongs to set 3. In the set 3, 8, 8 was not there. So it
Was
doesn't belong
not
to set
there.
3. Therefore, fourth object is included. Because of that only we got 4, 4. Now I
Okay,
should take an order
got
pair,
it.
8, 8. From this, I should subtract the profit and weight of the fourth object. So this is profit is 6 and the weight is 5. So the order pair is how much? 2, 3.
2,
So now I should consider 2, 3. So now this was the first one. Now second one, 2, 3. Now I have to consider third object. So check whether it belongs to S3. 2,
Yep,
3. Yes,
it belongs to S3.
And 2, 3 belongs to S2. Check
S2
whether it belongs
also.
to S2. S2, 3 is there here also. It means this is not because of the third object. So therefore, third object is not included in the
Not included.
Then, now next step is I will consider second object. 2, 3 belongs to set 2 for second object 2, 3.
There
Now,
should
does it
be
belong to set 1?
2, 3,
But
not 2, 2.
3
Yeah,
doesn't belong to set 1. So 2, 3 was belonging to set 2 and 2, 3 doesn't belong to set 1. So
that
therefore,
means
this is because of the second object. That is
second
included.
object
Now,
was
what is the profit
included.
and weight of the second object? 2, 3. So when you subtract 2, 3 from this one, 2 minus 2 is 0 and 3 minus 3 is 0. So this gives 0, 0. Now first object I will consider. Now the step is 4. So 0, 0 belongs to set 1 and also 0, 0 belongs to set 0. Therefore first object is also not included.
Not
0,
included.
0 belongs to S1 also, S0 also. It means this is obtained not because of the first object.
S0
So first object
means
was not included. Then the
there
solution
was
is from bottom.
no
0, 1, 0, 1.
object
So the answer
selected.
is 0, 1, 0, 1. So these two objects are included. See, the profit is 8. So we got the same solution with the help of sets also. So this is one more method. That's all about 0 knapsack problem. Leave a comment and let
सो 01 नैपसैक प्रॉब्लम कंप्लीट हुआ हमारा. अब हम लोगों के पास में कुछ वीडियोस बचे हुए हैं. सो वी हैव 84 वीडियोस. आई थिंक अप अंटिल दिस वीडियो इज आवर ओल्ड प्लेलिस्ट काइंड ऑफ थिंग. सो वी आर ऑन द 54th video and we need to go up until 79. ठीक है, तो हम लोगों के पास में 25 के अराउंड वीडियोस अभी और बची हुई हैं देखने के लिए और हम लोग उनको एक एक करके देखेंगे, कंप्लीट करेंगे. एक दो ही वीडियो मुझे बड़ी दिख रही हैं, उसको भी देखेंगे. 31 मिनट का है या 39 मिनट्स का है. बाकी यार मैं सोच रहा हूँ ना, इन सारी वीडियोस का अब मैं एक प्रॉपर लाइक सारी जितनी भी एल्गोरिथम्स हैं इनका मैं प्रॉपर एक एनिमेटेड काइंड ऑफ थिंग बनाऊँ और उसको मैं मेरे रिवीजन के लिए भी काम आएगा और उसको मैं एक नई प्लेलिस्ट में एक एक करके पोस्ट करूँगा ताकि लाइक आप लोगों की भी हेल्प हो अगर जो भी देखना चाहते हैं, और मेरी भी हेल्प होगी कि मुझे कभी फ्यूचर में देखना है तो मुझे यूट्यूब पे लाइक ईजिली मैं सर्च कर सकता हूँ और देख सकता हूँ. तो आज के लिए बस इतना ही. मिलते हैं नेक्स्ट वीडियो में, नेक्स्ट लाइव में, नेक्स्ट किसी वीडियो के साथ. तब तक के लिए बाय बाय, टाटा, टेक केयर.